copyright strike because of the music in the background. Alright, so today we're talking tan graphs. There's some major differences for tan, that's why we do it separately. The first difference is that we only have to plot 3 points instead of 5. The second major difference, we can't use the terms max, mid, and min. We'll see why in a minute. So we're going to change those to be upper, mid, and lower. That's just like a language thing. We've been using max, min, and mid. We could kind of still use them, but I want to be proper. So upper, mid, and lower is what we're going to change for this. And then here's my favorite word in math. We're going to have two vertical Anybody want to try to guess how to say that word?
Asymptotes.
That's close. Anybody else want to try to guess? It's a great insult if you want to insult someone.
Yeah.
We will have two vertical asymptotes. Asymptotes. Determined by dividing pi over 2 by the frequency. So usually when we do trig graphs, we divide 2 pi by the frequency. But for the trig graphs, for tangent specifically, we divide pi over 2 by the frequency instead. So I'll show you in a second what an asymptote is. It's fun to say, asymptote. Asymptote. All right. Question 1 says graph y equals 2 tangent x plus 3. Label the axes with an appropriate scale. Indicate asymptotes with a dotted line. So just like we've been doing, let's figure out these three numbers. The midline is 3. So this number is 3. The amplitude is 2, so we're going to go plus 2 minus 2 to make our other numbers here, which is going to be 5 and 1. Looks like we have enough room to just label this normal. 1, 2, 3, 4, 5. -1, -2, -3. Remember, we do these three numbers to determine our y scale. We have to see if we have to make adjustments.
Tangent.
Yes,
What
tangent.
You can't do tangent.
Alright, so a tangent graph, we said we just have to make 3 points. These numbers are the 3 points we're going to use, the 3 y coordinates we're going to use. The mid is right there, 3. The upper is 5. The lower is 1. At the start, a tan graph just looks like a diagonal line, but it is going to do some weird stuff. I told you it was a weird graph. So far we haven't seen any weirdness. But trust me, it'll get weird. Alright, let's calculate the asymptotes. I told you to calculate these. This is the x label for them. It's pi over 2 divided by this number in front of the x, the frequency, which is 1. So our asymptotes are pi over 2. And we're always going to have two of them. We're going to have a positive one and a negative one. So this label here, the next grid line we're about to use, is pi over 2. And going the other way, this one's negative pi over 2. So normally when we do sine and cosine, we do one label and that's where it finishes the cycle. For tangent, you have to figure out where your asymptotes are. Asymptotes are indicated with dotted lines, dashed lines. When we did sine and cosine, we did dashed lines temporarily and then I told you to erase them. These are part of the graph. Do not erase them. They are supposed to be here. The sine and the cosine ones, if you want to draw them, they're just guides for you. You should erase them. And now, in fact, I'm going to just tell you erase them when you're done. Most of you probably aren't doing them anymore because they were just there to help you. Alright, an asymptote is a line in math that a graph approaches but never hits. So this graph is going to go really close to that dotted line without hitting it. It's going to get closer, it's going to get closer, it's going to get closer. It's going to start looking like it's going straight up in the air. But really, in reality, it's getting closer and closer and closer to this dashed line without ever hitting it. Same in the down direction. It's going to go down and closer and closer and closer. It's kind of hard to draw a line that's getting closer without actually hitting. It just ends up looking like a vertical line. It's sort of a vertical line, but it is mathematically getting closer to that. So that's a tangent graph. I told you it was weird. That's weird, right? If I graph several cycles of this, all you're going to see on your calculator is that it just keeps doing what we just graphed. It just keeps doing that over and over again. Your calculator doesn't show the dotted lines. You need to know that every time the graph rises dramatically, it's approaching that dotted line, that invisible dotted line that's not on our screen. It just keeps approaching it as close as you can get. And if I go in my table and I look at pi over 2, look at that, I have an error. The graph got so close to the dotted line that it actually just disappeared. If it actually hits that dotted line, it goes away because you end up dividing by 0, which you can't do in math. So every pi over 2 on your table is going to be an error. If I keep scrolling, look at error. This one doesn't say error, but this number's like basically a million. It's basically infinity, right? That's what these errors mean. Same with this one. It's basically a million. Okay? So do we understand how to do a tan graph now?
Yep.
I know these are all diagonally lined up and we're going to be really tempted to just do a straight line. But really, you need to have a kind of a vertical line that curves into a smooth curve and then curves back into a vertical, almost a vertical. Alright, so do your best to make it curved and not just a diagonal line. Let's do question 2. Same process as the last one. Upper, mid, lower. Do you see why we can't use max, min, mid, min? Because there isn't a maximum on these graphs. They go up forever. I can't call something a max when there's going to be an arrow coming out of it going up higher. And we also are going to calculate the asymptotes. So in this question, our mid is -1. We're going to go up 4 to get our upper and down 4 to get our lower. So we get 3 and -5. Looks like we have enough room to count by ones again. So 1, 2, 3, 4, 5, 6. Your asymptotes are 2 pi divided by, it's pi over 2 divided by this number. So pi over 2 cut in half. Pi over 2 cut in half. If I have half a pi and I cut that half a pi in half.
1/4 pi.
Yeah, it's a quarter of a pi now, pi over 4. So our label is going to be 2 over. It's going to be negative pi over 4 and positive pi over 4. So our 3 dots, 3, -1, negative 5. They always line up nice and diagonal, but we're not just going to connect them with a straight line. We're going to give them some curve. The asymptotes have to be vertical dashes that show our graph is going to get close to these, as close as it can possibly get without hitting. So I'm going to try to do this as smoothly as I can. Let me move this a little so I have more room. This is a little tougher to make curved because the lines are so spread out. So there we go. That's what our graph looks like. Any questions? Okay, I'm going to tell you to go try number 3, and when you do number 3, I want you to notice that it's a negative tangent. What could possibly change about our graph with a negative tangent? Our 3 diagonals usually go uphill, right? So when it's negative, our 3 diagonals, same process, but our 3 diagonals are going to go downhill. Okay?
No, I'm just trying to get bored. If you don't have to harass me.
I'm not harassing you.
Alright, so number 3, this is what your answer will end up looking like. Our midline was 4, which is not really a midline anymore. Our amplitude, which is not really our amplitude anymore, is 2. So we add 2 and subtract 2. 6, 4, and 2. Because it's negative, it's going downhill instead, but everything else is the same. Our asymptotes, pi over 2 divided by 5 pi works out to be 1/10 or 0.1. So that's why my x-axis labels are negative 1/10 and positive 1/10. Other than that, everything is pretty much the same, right?
Well, I'm actually not done.
Any questions on number 3? I know how to do this just fine. So if I do y equals tangent pi over 2x plus 3, I did my upper, middle, and lower just like normal. My asymptote works out to be plus or minus 1. I did my graph like normal. The only thing different about this question is that it says keep graphing until you get to negative 3 on the x-axis to the left, and keep graphing until you get to positive 3 on the x-axis to the right. So if my asymptotes were negative 1 and 1, what that means is that this graph, it just needs to be copy and pasted to the left once and to the right once. Because the distance between these 2 dotted lines, while it was 4 squares, it represented 2 as a width, right? Negative 1 to positive 1. So if I need to go 2 more to the left, that's going to be the same exact thing again. And then to the right, it's the same exact thing. So this question is the same exact process. It's just this one's going to ask you to do one extra thing, which is, hey, keep graphing until you get to negative 3 on the x-axis left, and keep graphing until you get to the x-axis 3 on the right. Okay? So it's just the same thing, copy and pasted.